Okay, in this video, we're going to be talking about the relationship between polar and rectangular coordinates. Given point P with polar coordinates r theta, the corresponding rectangular coordinates x and y are given by, and everything revolves around this drawing that I've made right here. If you've got a point right here, and that point is in the coordinate plane, the rectangular coordinate, and that's x, y, that means you go over x units and you go up y units. Well, that exact same point written in polar coordinates means that you go out r units and you roll up theta units. So therefore, that x, y, and r theta can be related by using this drawing. And we know that sine and cosine, let's go over that. We know that the sine of theta is equal to y over r, and that we've covered this earlier, and that the cosine of theta would equal x over r. Now, if we multiply in both of these equations, both of these sides by r, we get this relationship. So therefore, x is equal to r times the cosine of theta, and we can remember that relationship because we know that x relates with cosine and y relates with sine. And if we can just remember that, plus if we're dealing with a unit circle, then x will equal cosine and y equals sine. However, if we do have that radius, we do have to multiply by it. So there's the relationship. So what we're going to do now is we're going to convert each of these polar coordinates into a rectangular coordinate, and it says round if we need to. So if we've got, this is 2 comma 5 pi over 3, and 5 pi over 3, that is 600 degrees, or excuse me, 180 divided by 3 is 60. 60 times 5 is 300. So this is 2 comma 300 written in degrees. So that's going to be located somewhere right in here. So there's our point. So the way that we're going to do this, now you can use some basic trigonometry. If this is 300, we know that this is 60. We know that the radius is 2, and that's a 30, 60, 90 right triangle. So the short side, which is across from this 30, would be half of that, and then this would be root 3. So you could use that. That's one way of doing it. And the x and the y would be equal to, the x value would be 1, and the y value would be a negative root 3 because you went down. But again, you can do it this way. Your x value will equal r. Let me go ahead and put it. R times the cosine of theta, which is 5 pi over 3. And your y value will equal r times the sine of theta, which is 5 pi over 3. And that is the relationship. So 2 times the cosine of 5 pi over 3 would be 2 times the cosine of 300. And again, here's my angle. I've already drawn it up here. The cosine of 300 is a half. So 2 times a half is 1. 2 times the sine of 500 will be 2 times. Now the sine of, it's not 500, excuse me, 300. The sine of 300 is going to be negative because it's in the fourth quadrant. And it's going to be root 3 over 2. Multiply, these cancel, and leaves you with negative root 3. And that x and y corresponds exactly with this. So you can do it either way. You can either draw it, or you can just do it again. The relationship is x is going to equal r times the cosine of theta, in this case 3 pi over 4. And let's go ahead and change that to 3 pi over 4. Pi over 4 is 45, so 3 of those will be 135 degrees. We'll change it to degree measures. And our y value will be negative 6 times the sine of 135. 135 is in the second quadrant. It has a reference angle of 45 degrees. All students take calculus. The only thing that's going to be positive is sine. So my cosine will be negative, so I have negative 6 times negative. And then your reference angle again is 45. Cosine of 45 is root 2 over 2. The 6 and the 2 reduce, leaves you with a 3. Negative times negative is a positive 3 root 2. The next one, negative 6 times the sine of 135. Since you're in the second quadrant, sine is positive. Your reference angle there is 45. The sine of 45 is root 2 over 2. 6 and 2 cross cancels and leaves you with negative 3 root 2. So your x value is 3 root 2, and your y value is negative 3 root 2. Number 3, let's convert these, again, polar coordinates to rectangular. So you can actually just do it like this. The x value is going to be r, and now this is polar and this is rectangular. The x value is going to be r, which is negative 1/4, times the cosine of theta, and I'm going to write that it says negative 90 degrees, and my y value will be r times the sine of negative 90 degrees. So that's going to be my point. So my x value is going to be negative 1/4 times the cosine of negative 90. Now, again, if you're not comfortable working with negative angles, you could actually add a rotation to that. Negative 90 is the same thing. If you add 360 to it, coterminal would be 270 degrees. If you would rather work with an angle between 0 and 360. 270, the cosine is going to be 0. And then your y value was negative 1/4 times the sine of 270, which is negative 1. So therefore, my point in rectangular coordinates, negative 1/4 times 0 is 0. Negative 1/4 times a negative 1 is a positive 1/4. So we should, if we graph this correctly, should be in the first quadrant. And that polar coordinate, if you go out negative 1/4, which means you have to go back, and then spin a negative 90 degrees, which means clockwise, you should end up somewhere in the first quadrant at about the same rectangular, actually not the first quadrant, excuse me. This is going to be on the y-axis at 0, 1/4. And that does make sense because of that 90 degrees, that would be a quadrantal angle. Number 4. Again, your x value, here's your rectangular coordinates. Your x value will be 7 times the cosine of, and again, I don't want to work with negative 5 pi over 6. I'm going to do a couple of things with that. First, I'm going to change it to degrees. It's going to be negative pi over 6 is 30, so 5 times 30 is 150. So it's negative 150. And then if you don't want to work with a negative angle, let's add a rotation to that. So let's add a 360 to that, and it gives you 210 degrees. So we're going to have this angle is the same thing as 210. So 7 cosine 210, and your y value will be 7 times the sine of 210. 210 is in the third quadrant. The reference angle is 30 degrees. So therefore, third quadrant, all students take. So therefore, sine and cosine are both negative. So 7 times a negative, again, your reference angle is 30. Cosine of 30 is root 3 over 2. And your y value, 7 times the sine of 210. Again, third quadrant, sine of 210 will be negative. Your reference angle is 30. Sine of 30 is 1/2. So your x and y coordinates will be a negative 7 root 3 over 2 and a negative 7/2. Number 5, more of the same, except for this one's already in degrees. So therefore, your x value will be r times, again, this is r theta, r times the cosine of theta. And your y value will be r times the sine of theta. Now, the problem with 140 is not one of our common angles, so we will have to type that in our calculator, which will be just as easy. 9 times the cosine of 140. Now, since 140 is a second quadrant angle, this should be a negative. This should be a positive. 9 times cosine of 140 gives you negative 6.89, and 9 times the sine of 140 gives you 5.79. So therefore, you see an angle, negative and a positive goes left and up. That would be a second quadrant angle, which is what it should have been. And then the next one, number 6. Again, your x value will be r times the cosine of theta. And again, theta, this is 180 divided by 15. That'll be a 12-degree angle. So that'd be the cosine of 12 degrees, and your y value is the r times the sine of 12 degrees. And again, it's entirely calculator work. Your x value is going to be negative 3.42, and your y value is going to be negative 0.73. There you go. And again, that's your rectangular coordinates. Now let's do it backwards. Let's convert rectangular back to polar. And again, we're going to use that exact same drawing. Let me sketch it out again. And to work this backwards, now here's what we're going to do. We know that the three lengths of this triangle, x squared plus y squared would equal r squared because of the Pythagorean theorem. So therefore your r value is going to be the square root of x squared plus y squared. And again, that is just simply because of Pythagorean theorem. Now your angle though, how do we find our angle? Well, here's what we can do. If you're given your x and y values and you're looking for your angle, we know that the tangent of my angle would equal opposite over adjacent. So therefore we can move that tangent over and I would see that my angle in terms of x's and y's would equal the inverse tangent of y over x. So again, I could do y over x, take the inverse tangent of it, and that gives me my angle. So therefore, again, let's convert the other direction. Here we have rectangular coordinates. We have x's and y's, and we want to convert them into r's and thetas. So here's what we do first, and which, by the way, let's read our directions. Convert each to rectangular, or from rectangular to polar, round to the nearest hundredth or 2 decimal places, and if your angles between 0 and 2 pi, give 2 possible solutions. So we don't want just one answer. We want to give 2 possible answers that could be these points, because again, we know there's multiple points because of coterminal angles that gives us the same values. Okay, first off, we need our radius. So if our rectangular, and again, you can sketch this out if you want to. To plot this point, you would go right and you would go up. How much would you do each? How much right would you go? How much up would you go? Well, you go right 2 and you go up 2 root 3. So to find out this r value, again, it's simply Pythagorean theorem. You're going to do a squared plus b squared. Now, how do you square this? You square each piece. This is a 4 and a 3. 4 times 3 is 12. So a squared or x squared plus y squared equals r squared. 16 would be r squared, so r is 4. So there's your radius. That's this value. Now, how do we find the angle? We do the tangent of the angle is opposite over adjacent. Now, they've done you a favor here. They give you one that you know. So the inverse tan of root 3, the tangent of what angle is root 3? Well, I know that there is a couple of angles there that gives me a root 3. So let's make sure that we get both of them. The first of those angles being a 60-degree angle, or we can call that pi over 3. And that's going to be where this angle is located since we are in the first quadrant. We can write this as r theta is going to be the radius is 4, because that's how much we go out, and then we go up pi over 3. However, there is another angle that's equal to the tan that's equal to root 3. That other angle would be a third quadrant angle. But the only problem is here is this x and y should be in the first quadrant. So what we could actually do to find this other angle, again, we could use that reference angle. It's going to be 4 pi over 3 is this other angle, which would be 240 degrees. However, if we went out 4 and we rotate 240, we actually end up down here. So what we could do is instead of going out 4 and, go out 4 and rotating all the way around to here, what if we went out a negative 4 and rotated? Remember we said before that there's a couple of different ways that you can find other points that would be, I guess you could say, coterminal with this one. You could add rotations on here. You could add a 2 pi or subtract a 2 pi to find coterminals, or you can make your radius negative and then add a half rotation, which is actually ends up to be that other angle that was that had the same tangent value. So therefore, there's 2 points that have that exact same location. Okay, let's do another one. To find our radius, we're going to do the square root, or you can just do x squared plus y squared equals r squared. It'd be fine. So let's square this. And so we got 3 different things to square. We have 9 times 2, which is 18 over 4, whenever we square that. Plus, same thing actually, because we're squaring a negative, it makes it positive, and it also ends up to be 18 over 4. So x squared plus y squared equals r squared. This would be 36 over 4 equals r squared. 36 over 4 is the same thing as 9. So my r value must be 3. Or if you want to get technical about it, it could be either positive or -3. We have two different radii there. So in order to obtain that point, which I like to sketch this out, we have a positive and a negative. This point's going to be somewhere down here. Okay. Now let's find our angle. So my radius is 3. The distance from here out to here is going to be a radius of 3, or again, we can obtain it by doing a radius of -3. Now my theta, I know that the tangent of theta is equal to y over x, which is actually something over itself. The only difference is one is negative, one is positive, so that's going to be a -1. So my angle is actually going to be, okay, what angle gives me a tangent value of -1? Well, if you remember, tangent is defined between 0 and 180. My reference angle there, let me try this, a 45-degree angle has a tangent of, excuse me, a 45-degree angle has a tangent of +1. However, I need an angle over here or down here. Excuse me, I was wrong. That has a tangent is -90 to +90, so this angle right here would be a -45 degrees or -π/4. So a couple of different answers there. If we go out a radius of 3, rotate down -45 degrees, that's the exact same point. So radius is 3, the angle is -π/4. Or again, what we said before, we can make our radius negative, and we can add a pi to this, and it's going to give me the exact same point. So add a pi to that, and that would be 3π/4. So both of those points should end up in the exact same place. Now, one thing I did notice, I forgot this, they want an angle between 0 and 2 pi, so you can add a rotation to this, and that would bring you up to, if we do that, let me zoom in just a bit, that would be a +7π/4 if you did do that. And then again, same thing, you can subtract 4π/4, get the exact same answer. Number 9, you have, first off, our x squared plus y squared equals r squared. When you square a negative, it's positive. Square the top, square the bottom gives you 3/4. Plus, y squared is 1/4 equals r squared. X squared plus y squared equals r squared. This is 3/4 and 1/4 is 1 whole is equal to r squared. So r is going to be the square root of that, which is positive or -1. So there's your radius. Your angle, we know that the tangent of theta is going to be y over x. That's going to be a negative over a negative. I'm not even going to put the negatives. I'm just going to put 1/2 over √3/2. Flip and multiply, the 2's will cancel and leaves me with 1 over √3. When you rationalize, you get √3/3. The angle between -90 and +90, or again, it really doesn't matter the angle as long as it ends up in the right place. The tangent of what is √3/3? That would be a 30-degree angle, which is pi/6. However, we know again that those values are going to repeat. And pi/6, I don't know if that's going to give me the right spot. A negative and a negative, this point should be a third quadrant point. So let's always double check that we end up in the third quadrant. So we understand that if we're going to use a radius of +1, look at this. A radius of +1 is going to have to rotate all the way around to here. That's not a pi/6 rotation. That's going to be, let's see, the tangent. Where's tangent √3/3? Not just at 30 degrees, but also down here at 210 degrees. So there's two different answers there, 30 degrees or 210, which would be 7π/6. So let's see if we can figure out what goes with what here. In order to obtain this point, if you go out a radius of 1, you would have to rotate the 7π/6. So 1, 7π/6 would be one of the angles that it ends up here. However, what if you rotate or go out a radius of -1? Then you can just rotate this, which would be the positive pi/6. So there are your two angles. Okay, let's do another one. Number 10. This one should be an easy one. This is actually, if you were to look at this triangle 6 6, this is a 45 45 90 right triangle. So you can sketch it if you would like to, or you can do the x squared plus y squared equals r squared, but the radius is going to be 6 root 2, positive or negative 6 root 2. So there's your radius. Your angle is going to be the inverse tan of y over x, which gives you -1. So the tangent of what angle is equal to -1? That's going to be a -45 degree angle here, which you can write instead of -45 degrees, you can write that as 315 degrees. That's the same angle. Or you're also going to have an angle over here in the second quadrant that has an angle of, or excuse me, has a tangent of -1, and that's going to be I'm not going to put equals, but theta is also equal to 135 degrees. Now, where do we need our point to end up? -6, +6. That's going to be -6, +6 is somewhere up here. There's my point, -6, +6. So therefore, let's see which of these go with which of these to figure out where that point's located in our thetas. If we go out a radius of 6 root 2, and then we need to rotate this angle, which is going to be the 135, which again you can write as 3 pi over 4s. However, if we do a radius of -6 root 2, which would be here, we're going to have to rotate a whole lot farther. We can either go backwards. I believe that would be backwards 45 degrees, which is a -45. However, they want their answers between 0 and 360. This is -45. Same thing as 315 degrees, which would be 7 pi over 4s. So there's your two polar points. Two more. We know that, again, to find r, we know that x squared plus y squared is equal to r squared. So 52 is r squared. So r would be plus and minus. The square root of 52 would be 2 root 13. The angle is going to be the inverse tan of y over x, which would be -4/6 or -2/3. I'll just go ahead and reduce it. You don't have to reduce it. So those angles. Okay, a negative angle or a negative tangent. That's going to give me a fourth quadrant angle. You can type it straight into your calculator because this is not a common angle, and I'm going to get -33.69 for my calculator. However, I don't want that angle. I want an angle between 0 and 360, so all I have to do is add a rotation to that, and that's going to give me 326.31. Now I've got a problem because that's not going to be my only angle. Okay, now these are a little bit tougher. I've got to figure out how can I find that other angle. Well, if you look back to the very first part, it gave you your reference angle. Your reference angle here is going to be a 33.69 degree reference angle because this first angle that you found, this -33.69, is going to have the exact same reference angle as all of these tangent angles. So therefore, that's my reference, and you can put the reference is equal to that. So where is tangent negative, though? Tangent is negative down here, like we found out in this fourth quadrant. But tangent is also negative over here in the second quadrant. So I need this second quadrant angle that has a reference of 33.69. So do 180 minus 33.69, and that's going to give you your other angle for theta. So theta is not only equal to this, but theta is also equal to 146.31 degrees. So there's your two thetas, theta 1 and theta 2 if you want to call them that. So now which quadrant is this in? 6, -4 is going to be somewhere. We can erase all this now. We are looking for an r and theta that ends us up in the fourth quadrant. So if we're going to use a radius, let's say my radius was, the first one was 2 root 13. If you have a radius of 2 root 13, a positive radius, in order to end up in the fourth quadrant, you would have to rotate a total of 326.31. There's your first r theta. If you have a radius of -2 root 13, which would end up over here, you would have to rotate a total of 146.31. Those two answers go together. There's your two r thetas. And number 12, the last one. X squared plus y squared is equal to r squared. So r is going to be root 50, which is positive and negative 5 root 2. Your inverse tan, okay, the inverse tan theta will equal the inverse tan of y over x, which is 7. So let me draw a line. So theta, the inverse tan of 7 is going to be equal to 81.87 degrees, which is really nice because that's a first quadrant angle. So that's going to be my reference angle. That's my first theta. My second theta, now where is tangent positive? I'm going to have a first quadrant answer, and I'm going to have a third quadrant answer. So my reference is, again, 81.87. So this is 81.87. So let's do 180 plus that 81.87, and I get 261.87. There's your two angles. So what quadrant is this in? Negative, negative. That's a third quadrant point. So how do I get a third quadrant point? Okay, let's say, what if I go out, let me sketch it down here. What if I go out 5 root 2? How do I end up in the third quadrant? If I go out 5 root 2, I'd have to rotate somewhere between 180 and 270. So obviously, that's going to match up with a 261.87. Well, second scenario, what if I go left 5 root 2? What if my radius is a negative 5 root 2 and I want to end up in the third quadrant? Then I'm only going to have to go less than 90 degrees. That'd match up with the 81.87 degrees. And there's your 2 points.